The college has been using a sample of radium-226 as an alpha particle source for 30 years. Initially, the mass of it was 15 micrograms. Determine the initial number of atoms in the sample, right? Okay, so what you're going to do is you're going to go mass. Notice that that's micro, so that's 10 to the minus sixth, right? So mass over molar mass equals n, right? And then you're going to do n times Avogadro's number, right? And you're going to get the number of atoms. And it's a lot. It's on the order of 10 to the 16th atoms. Okay. It's somewhere between 3 and 4 times 10 to the 16th nuclei. Okay. And what's the molar mass of 226? I really hope you're not asking that. It is, they give it to you on the front. It's 226. I actually typed in the 0.0, I think it's 0.0254, right? Because you can, right? They just use 226 in the mark scheme, so that's that molar mass. It's from the previous page, right? Right? And then the number of atoms after 30 years, right? So this is your, you call that your n naught, right? Okay, and then just use n equals n naught e to the minus lambda t. On the previous page, they tell you this, right? In fact, we actually explained what it meant, right? So look at that. Notice that this is 30 years, and that the constant they give you is 4.3 times 10 to the, and you'll have to look it up, okay, on the previous page, right? But that is in probability per year, okay? So plug that in, and then put the 30 in for this, right? And you'll get a number that's, really, that's a small number, and so after 30 years, it's pretty much mostly still there, okay? So there you go, right? Then it says the average, find the average activity of the sample during the 30-year period. And what they do, it's sort of funny, is that they take these numbers, which are almost identical. They take n naught, and then they subtract n, which is how many decays they had, and then they divide by, well, you should divide by seconds. Really, when you say activity, it should be decays per second. They allow answers in decays per year, right? Just simply because everything is in years, right? So again, what they do is they go n naught, the original amount that you figured out here, minus n, the amount that you get there. Now don't round it, because you'll throw the baby out with the bathwater, and how sad is that, right? Divided by 30 years, right? And then just remember that 30 years, 30 times 365. Do you want to go 0.25 roughly? 365, roughly a quarter, right? Times 24 hours in a day, 3,600. This is how many seconds there are in a year, right? 30 years times 365.25 times 24 times 3,600. And that would give you decays per second once you got decays per year. What I did, by the way, was oh, there's no eraser. What I did was I didn't do that at all. I used the idea that activity is lambda n, right? Okay, so I used an average n. So I did the activity, which is 4.3 times 10 to the minus 4th, times, I did the average, so n plus n naught over 2. You get exactly the same thing. So I thought that was the way to do it, but they didn't do it that way.